Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today, we're going to look at some analytical geometry, and we've taken this from the 2018 November DBE exam. Right, so they've said to us in the diagram below, we've got P10, Q63, and R9 minus 2 are the vertices of a triangle such that PQ, all right, equals QR. So that's very important. Let's mark that in. So it's this PQ over here, okay? And that equals QR. So it equals that line over there. We just need to make sure we remember that. And PQ is perpendicular to QR, which they've noted for us already. Right, T is a point on PQ such that T is the midpoint of PQ. Also something important for us to remember, so let's mark that. S is the point of intersection of RQ and the x-axis. Okay, so that's important to know. And V is a point on the x-axis such that QSV, so that's that angle, is equal to 121 degrees. And we've got QPS, which looks like that, gives us angle theta. Right, so dealing with 2.1 in this particular question, they've said to us 2.1.1 length of PQ. So we need to determine the length of PQ. Leave your answer in surd form. So we're going to use our distance formula here. Okay, so we're looking at PQ, which is this one over there. Let's first write down our distance formula. So we know that PQ is going to be equal to, we're going to draw our long square root sign, and then we're going to have two brackets. Okay, we're going to add those two brackets up. Then we're going to have x2 minus x1, y2 minus y1, and that's going to give us the distance of PQ. Right, let's sub in our numbers now. Excuse me. Right, so let's sub in our numbers now. We've got two coordinates, right? So we've got P and we've got Q. Okay, so it doesn't matter which one you use as the first one, as long as you use it consistency. So what I like to do is I open up my two brackets, then I have my minuses there, and then I'm going to use P over there as my first, which is going to be 1 and 0, okay? And then Q as my second, which is then going to be 6 and 3. All right, so that helps me remember to put the same coordinate in the same position. All right. Right, so once we've done that, we say 1 minus 6 is minus 5, so that would be plus 25. Then we've got minus 3, so that would be plus 9. Okay, equals, we're going to square root this one, and that's going to be the square root of 34, and we know it's units. Right, so that gets us the distance of PQ. So I'm going to write it up over here. So that is 34, and that would mean this is also 34, just in case we need it for later. All right, now we need to work out the gradient of PQ, right? So what is our gradient formula? Well, the gradient formula is going to be y2 minus y1 over x2 minus x1. Right, so let's plug in our points. Let's use P1 as our first one. So that would be 0 over 1, okay, and then we've got Q, okay, and that therefore would be minus 3 minus 6, right? So what would that equal? It's going to give us minus 3 over minus 5, so therefore the answer there should be 3 over 5. Does that make sense? If we look at that curve, so PQ, it does look like a general slope upwards, so we expected a positive gradient and a general sloping gradient, so that seems to be the right answer. Great stuff. Right, lastly, moving on to the coordinates of T. I'm going to give myself a little bit of space now. I hope you don't mind. I'll leave that question in over there. Okay, so this is the last little bit of this video. We're going to determine our midpoint. So we're looking at the coordinates of T. Now T, they've said to us, is the midpoint of this particular line. So let's use our midpoint formula. Okay, what I like to do is I go straight into it. So I'll say the coordinates of T, and then I've got x1 plus x2 over 2, y1 plus y2 over 2. Right, so we're going to use our coordinates again. So we're going to have open up over 2 over 2. Right, so we've got x1. So let's use this point first. So that would be 1 and 0. And we're going to add our second point is that one over there. So it's going to be 6 and 3. Right, we can simplify that. So that's going to be 7 over 2. And that's going to be 3 over 2. And that should get us the right answer. All right, so that's all. Those are the basics when it comes to analytical geometry. Hopefully they helped you out and hopefully they prove useful. Very special thank you to our sponsor for making this video possible. Be sure to read all about them in the description below. Also, head over to our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question. We'll respond with a personalized video just for you. Until the next time, stay epic.